I'll do a quick review over the final, semester one final. The first question, you are plugging into, when you go to plug in something into a piecewise function, you need to figure out which inequality that thing fits in. So if I'm going to plug in 2, 2 belongs in between 0 and 3. So I would plug in 2 into x squared plus 2x, and the answer to that would be 8. Number 2, you're plugging in a cubed, so that would say negative 7 times a cubed squared plus 3a cubed. Really, the only question here is, what do I do with these exponents? And the answer to that is multiply them, so the answer is D. 3 and 4, you want to try to factor this. Again, you should always try to eliminate the answers that don't really make sense. This one is clearly wrong. It's very different from the others. It's 125 x cubed plus 1. So the binomial you don't change the sign. It's 5x plus 1, so it's not 5x minus 1 there. Really, the only question is, do I change this middle sign or no? And the answer to that is yes. So the answer is B. But with factoring, what you can always do is you can always type in the original problem, and then you can also type in the factored form of that. And if they give you the exact same graph, then that's the answer. So notice if I take that blue one away, it's the exact same graph as the original, which means the answer is 25x squared minus 5x plus 1. If that were plus, notice those aren't the same graph. So it has to be the minus one. So you could always use that strategy. You could use it on number 4 as well. On number 4, all you can do is factor out an x. You're left with x squared plus 16. This is a sum of squares. That does not factor. B is the correct answer. A lot of people think that that is x plus 4 times x plus 4. That is incorrect. You cannot factor that. So the answer is B there. You could use the whole graph idea on Desmos on that as well. Number 5, you want to factor everything as best you can. So that's a plus 1, a minus 1. This would be a plus 10 and a minus 5. And then you can cancel things that are the same on top and bottom. All you're left with is what we have for answer D. A lot of those clearly don't make sense. So D is the only one that looks like it's the right kind of thing there. On number 6, you want to find the slope. We want to find slope-intercept form, so y equals mx plus b. The slope, y2 minus y1 over x2 minus x1. If you work through that, you get 4. The only one of these that has a slope of 4 is D. If you needed to, you would just take one of these points, I'll say use that one, and you plug in the y and the x, and you solve for b, right? Y equals mx plus b. So that would say that b equals negative 1. So there's my m, and there's my b. So it has to be 4x minus 1. If you have more than one point, you can always create a table in Desmos. Type these in. So negative 1, negative 5, 0, negative 1. And then if this button comes up, which it should, you can add regression, linear regression. There's your y equals mx plus b. If that doesn't come up, I would say make your table. It's going to plot those points, and then just type in the graphs until you find the one that goes through both those points. So 4x minus 1 clearly goes through both of those points, and that would be my answer. Number 7, the way you solve a compound inequality is you take the stuff on the inside. The first one, you just keep everything the same and solve that. The other one, you take the stuff on the inside, and then you change both of these things. So we're going to say less than or equal to negative 42. And we're going to solve that out. If you solved this, you would get v is greater than or equal to 11. If you solved this, you would get v is less than or equal to negative 10. So the answer has got to be A. On number 8, average rate of change. It's just slope, but we're given an interval. These are both x coordinates. So I've got the point 0 comma something and 2 comma something. So I have to come up with the y coordinates there. So I'm going to use the function to get the y coordinates. If you plug in 0, you get 1. If you plug in 2, you get 13. And then you're just going to do the slope formula, which would be 13 minus 1 over 2 minus 0. The answer to that is 6. Unfortunately, I don't have that as an option. I totally messed this up. So the answer is 6. just due to the slope there. On number 9, function transformations. Look, you have a graphing calculator. You can always plug these in to check it out. Down 2 is -2 on the outside. Right 9 is -9 on the inside, and reflected over the x-axis is a negative on the outside, so A is the correct answer. Number 10, domain and range. When you find the domain of a function, it's what x's can I plug in, right? So if I just think about this part of that equation, my x's would have to be greater than or equal to 3, otherwise I would have negative numbers inside the square root, which I cannot have. So I know the answer is A. My suggestion would be to graph it. And if you graph the square root of x minus 3 plus 4, you can see that the x's are all 3 or more, right? So 3 are to the right, and the y's are all 4 or more, 4 or above, and therefore we have that domain and range on number 10. Number 11, we want to work through the function composition here. We're plugging the function h into the function g. So this is going to go in for the t values. So we're going to have 4t plus 3 squared minus 3 plus 2 times 4t plus 3. Make sure with this part you write that twice and FOIL it. So that would be 4t plus 3 times 4t plus 3. And then we're going to FOIL that out. The very first term that you would get when you FOILed that out would be 16t squared. And nothing else in this problem is going to give me a t squared, right? Because it's just going to give me 8t plus 6, and I've got this minus 3. So my squared term has to be 16. I know at that point in time that's what that would be. But if you couldn't figure that out through that, just keep working through the algebra, combine like terms, you're going to get D. On 12, log properties, numbers in front of logs come up as exponents. So I would expect to see an 11 to the 4th and a 5 to the 24th. If you are adding, that turns into multiplication inside the log. So the answer is C. You could always just type this into Desmos. It will give you a value. And then figure out, if you type these into Desmos, which one gives you the same value as what number 12, the question gave you. 13, you have to know how to go from log form to exponent form. And that is the base to this exponent equals the stuff that's on the inside of the log. So a to the 4th equals 3x. I'm supposed to solve for x, so I divide by 3, and I get a to the 4th divided by 3. 14 and 15 are both equations. If it's a multiple choice test and you're solving an equation, you always have the right to just plug the options in for x and see which one of those, when I plug that in, is going to give me 110. Okay, so if you did that, you got 2 to the x minus 9 power, and then plus 10. I believe that's right. Yeah, plus 10. And I just want to know which one of these x values is going to give me 110, right? So what I would probably do is I would just make this into a table, and I would type in these x values that I have as options. So I believe the answer is this one, 15.6439. So if I just type that in, 15.6439, notice how that gave me something very, very close to 110. I would want to make sure that the other ones didn't give me something closer to 110, but that is my correct answer there, is 15.6439 for number 14. You could do the same thing on number 15, take these, plug them in for x, and see when you plug that in, which one gives you -4. The answer is C, -14/3. On 16, you're doing synthetic division. We put 2 in the box. 1, 6, -11, -6. We drop the 1, multiply by 2, and add, multiply, add, multiply, add. The remainder is 4. So our coefficients should be 1, 8, 5 with the remainder 4. The answer is B. On 17, the possible number of extrema. Extrema is turning points of a graph, and the number of turning points that a polynomial can have is 1 less than its degree. So I know that the possible number it can have is 3. So it's either A or D. To find the actual, I would just graph this and see how many actual turning points it has. This one we can rule out one of the answers because every even power has to have an odd number of turning points, and every odd power has to have an even number of turning points. So this is impossible to have 2 turning points. So the answer is D. But you could graph it and see how many times do you have a turning point, which is like a max or a min, right? So how many times do I hit a peak or a valley on my graph and turn and go the opposite way? The only answer there is that makes sense is going to be that it only has 1. 18, we are writing a polynomial. So these are the zeros. This means we have 3 as a 0 twice. So really what I would have is I would have x minus 3 times x minus 3 times x plus 4. And I would multiply all that out. But the easier thing to do would be to just graph these until you find the right one. Remember, if a 0 happens twice, the graph hits that 0 and bounces back. It doesn't cross through. So I expect to see that at 3, and I expect to see it crossing through at -4. The one that does that is C. If you took some time here and you graphed this, you would see that the graph crosses through at -4, but then at +3, it's going to hit the x-axis and go back up. And so that is option C. Number 19, find all zeros. Anytime the directions find all zeros, graph it in Desmos and look for x-intercepts. So we've got 3x to the 4th minus 11x squared plus 8. And I can see all 4 zeros. 2 of them are good numbers, -1 and +1. The other 2 are not so good. So the only 2 good numbers I got were -1 and +1. So that means B is not an answer because I didn't get -2, and C is also not an answer because I didn't get any of those good answers there. So I know I got -1 and +1, so it could be A and it could be D. What I would do, my other answers that I see are 1.63299 and negative that same number. So what I would suggest is you just type this in and see if that gives you that decimal. And if it doesn't, that means that this should give you that decimal. The answer is A. You could do synthetic division with 1 and then -1 and then end up solving a quadratic, and that would give you those last 2, but that's the easier way to do it. On 20, you just want to write this twice. 3 minus 5i, 3 minus 5i, and we're going to FOIL this out. When you FOIL that out, you get 9 minus 15i minus 15i plus 25i squared. This is -25, which if I combine that with the 9 gives me -16. And if I combine my I terms, I get -30i. The answer is B. On 21, we're just going to, I would say just graph this and tell me what it looks like. Hopefully you know what those things look like. An ellipse is the correct answer. That's like an oval shape. Okay, so if you graph that, you should see something that looks that, or vertical that, right? It's still an oval shape. But that is an ellipse. I would just plug that in and tell me what that looks like. On 22, the vertices are 5 and -5, 0. Those are x coordinates, so I squared that. I should see that underneath x, which means D is wrong. Also, C is wrong because this implies we have transformations, which would totally mess with these values, so C is also wrong. I would just say, remember this, the foci formula, which I will give you, it's right here. I don't just use these 2 numbers, right, to get that C value. I subtract those 2 numbers to get that C value. So if you're like, oh, 3, 9, that makes sense, that's wrong. Okay, so it's not just that number. It's if I subtract these 2 numbers and take the square root, that's how I get that number. So that would give me, 25 minus 16 would give me 9, and I square root that. That's how I get that 3. So the answer is B. On 23, the focus is at 0, 1/12, and the vertex is at the origin. It's a parabola. If the vertex is at the origin, again, there's no transformations. Don't pick that one. Vertex is at the origin. The focus is on the positive y-axis, which means my parabola has to go up. And if the parabola goes up, it's an x squared parabola, not a y squared parabola, so I know that that's wrong. And because it goes up, the value has to be positive, not negative. Positive would mean, or sorry, negative would mean it goes down. So the answer is B. You've got some information there on your reference sheet as well that you could use to get that additionally if you want to do it that way. 24, if you just graph this, you should be able to see, you graph this, you get the vertices are at 0, 7, and -7. So that is the correct answer there. The explicit formula on 25, my suggestion would be if you plug in 1 for n, you should get the first term. So your question should be, which one of these, if I plug in 1 for n, is going to give me -17? And that is D. 26, recursive formula, you're just saying what the pattern is. From one term to the next, it's multiplication by -3, which means D is the correct answer. That's the one that says we're multiplying by -3. 27, arithmetic sequence, we just want to find the 38th term. So on your reference sheet, you've got nth term of an arithmetic sequence, use this formula. So I'll copy that down. The 38th term is the first term plus 38 minus 1 times the common difference of 7. If you type all that into the calculator, you get 268. On 28, the sum of the infinite geometric series, the formula for that is A over 1 minus R. A is the first term, and again you have this on the reference sheet. A is the first term, which is 64. R is what we're multiplying by from one term to the next. So we are halving those numbers, so that's 1/2. And if you type that into the calculator, you get 128. I think that's the only option that even makes sense there, by the way. On 29, you can do summation notation in Desmos if you go to the functions button and scroll down, you can find it. It does always use n, so you just have to change your variable to n, but this is from 1 to 7 and it's 5n squared, so that would be a value, a sum of 700, which is D. Okay. So again, your reference sheet, you're going to get some stuff about conic sections. I hit on that just a little bit, but there's some stuff there that you could use if you needed to. You've got formulas for sequences and series that we just did, and then you have the quadratic formula. Okay, that's what you'll be given. It will be 30 questions, all multiple choice, Scantron. Hopefully things go well for you. If you have questions between now and your final, come see me.